What's up, everyone? Today we are solving the problem called heart problem from Codeforces, and here's what it says. Val is the teacher in a Val is the teacher in Paperfold University. The seats of his classroom are arranged into rows with m seats each. Val is teaching A plus B plus C monkeys, and he wants to assign as many monkeys to a seat as possible. Val knows that A of them only want to sit in row 1, B of them only want to sit in row 2, and C of them have no preference. Only one monkey may sit in each seat, and each monkey's preference must be followed if it is seated. What is the maximum number of monkeys that Ball can sit? Input. The first line contains an integer t, the number of test cases. Each test case contains four integers m, a, b, and c. Output. For each test case, output the maximum number of monkeys you can see. Right. I think it's a good problem. It's very clear what they're asking. Um, However, let's look at a few examples. So here we are given five test cases, and let's say on the first one, for example, you can see that we get the how many seats we have on each row. In this case, we will have 10 seats on both rows. That would be a total of 20 seats available. And then we get the value of A. Here the value of A would be 5. So that means that the number of rows in the first, sorry, the number of seats on the first row would be enough. And the same for the second row, because we know that five monkeys want to sit on the second row, which also has 10 seats. So let's say we get five seated on the first row and five seated on the second row. That would give us a total of 10 seats taken of the 20 available. So in that case, we would have 10 seats left still, and that would give us enough, exactly enough, to seat the remaining 10 requested seats. So that's an explanation for the first test case. We will look into the second one because it's also very interesting. But yeah, I mean, that's the main idea. I mean, we want to calculate ho- how the maximum number of monkeys that ball can sit, and we can do this by simply taking our total amount and then starting to subtract accordingly until we have a number of remaining seats, so to speak, and then we can see how much of those we can uh, we can give away, so to speak. So yeah, hope this becomes clear as we get into the coding. I will walk you through at least one more test case or one more input. So let's jump into it. Um, as you can see, I already have some basic boilerplate for the test cases, and we're interested in taking these values. Let's say int m, a, b, and c, right? And then we will take them from the standard input, very standard stuff. Yeah, it's M, A, B, and C. So that would be four values total. Great. So now, let's think about it. And in fact, let's go about this with the second example. Let me bring it here. Let's say we have this. All right. So let's see. This is our test case. And as you can see, we have that each row is going to have three seats. So if you think about it, in order to know how many of these six monkeys we can sit, we have to think, all right, so 6 is larger than 3 because in the first row, let's say something like first row, we have 3, and then on the second row, we have 3 as well. But 6 is larger than 3. So of these 6, only 3 will get seats. So yeah, will get seats. So basically, we have to, in every case, in order to calculate how many of the A monkeys will get seated, we have to see, we have to compare it to the number of seats on the first row, for example, and see which value is the lesser one. And what I mean by that is literally, let's say, taken A. This is for the number of seats taken in the first row. And to calculate this, we can do this. For example, we can say M, which is the number of seats available in the first row, and A, the number of monkeys that want to sit in that row. And here, for example, uh, M is going to be 3 and A is going to be 6. So the lesser value of those two is 3, which is how many monkeys we can sit. Hope that makes sense. And we're going to do that exact same thing for B. And we use M again because both rows are going to have the exact same number of seats. We get that. Exact same logic. And then, in order to know the remaining seats, if any, we can do something like this. Let's say remaining S, that stands for remaining seats, and we can take the original amount of seats available, which would be M times 2, and we can subtract how many seats are already taken at this point. And we can do that by adding taken A plus taken B, like this. And this would give us how many seats we have left. And then, in order to calculate out of those remaining seats how many we can take, uh, we just have to do this same operation but compare the remaining seats with C. So let's see, taken C, and here we take the minimum value out of the remaining seats and C to see how many of the sea monkeys we can sit. And then the final step would be to literally just, well, I like to do something like this. For example, let's call answer and say taken A plus taken B plus taken C. So this would give us our answer and we can print it just like this. So hope that makes sense. Let's give this a go with the sample inputs. I think its process is still running. Okay, let's see. And then we have 25, 30 to 84. 25, 30 to 84. Looks about right. So now let's test this for real. Hard problem. There you go. And let's submit it. No? Okay. Classic human verification. Let's hope it does not take that long. And it is taking A bit too long. Success. Okay. Let's see. Running test one. Accepted. Great. So hope that makes sense. About time complexity of this. For each test case, the time complexity would literally be of one because we are always performing the same set of operations. I mean, as you can see, there's no loops involved in this case. So hope that helps, and that's it.